This week's presentation will focus on the BIM used in DDP, how it was applied, and how it pursued economic efficiency in panel manufacturing. Structure is framework of building that deliver the load of the building to the foundation and ground. Modern architecture has a large reinforced concrete and steel frame. The DDP used a steel frame. DDP is the world's largest unstructured building. There were no domestic construction cases, and the interior space and exterior panel were in an unstructured complex shape, making it impossible to design the construct only with 2D type drawings. Therefore, we tried to secure the construction possibility of the project by introducing BIM from the construction stage. It was designed using 3D programs such as Rhino and CATIA in the field. They formed a BIM team and applied BIM to the construction stage. At that time, the design of 2D and 3D was carried out at the same time. Many discrepancies and errors occurred between the drawing and the 3D model. BIM information was exchanged as shown in the picture to catch these errors. BIM modeling is conducted with data processing based on 2D information of the designer and the information of the Rhino. In the steel frame field, information exchange was carried out in IFC format using specialized Tekla structures. Designing the DDP structure using BIM. As you shown in this video, trusses are connecting well without interference. They solved the interference between structure and equipment piping with BIM because it was difficult to check the interference with the 2D flat design alone. For optimization of steel member curvature, the design was changed from the left picture with smooth curvature to the right picture with 2 or 3 curves. Interference checks were also made through the member curvature optimization, construction, and BIM. Aluminum panel divided by appropriate size during the initial design phase. Panels are divided into size first, considering economic feasibility and constructability. If each panel is too big, the curved surface is awkward. and if it is divided too small, construction and labor costs are high. Through computer simulation tasks, optimal number and size of panels are calculated considering constructability and economic feasibility. As a result, the appropriate number of panels covering DDP was 45,133. Simulation results of 45,133 panel images colored red is secondary curved surface. It occupies 50%. Curved orange is primary curved surface, 22% occupied, and light green is flat, 28% occupied. Paneling with BIM three-dimensional modeling tasks utilize building information modeling. What is different from simple 3D modeling is that all computer-worked components contain building information. Aluminum panels surrounding the outside have architectural information about their own size and curvature, and are built and constructed based on their info. Let's watch a video explaining the unique value of DDP that could be implemented through BIM.
Dongdaemun Design Park and Plaza is a public space and building project on the site of a former stadium in Seoul in South Korea. The site area is steeped in history. Dongdaemun means Great East Gate and was one of 4 gates into Seoul during the Chosun dynasty. More recently, the area has become a hub for fashion, media and new technologies. Designed by Zaha Hadid Architects, the Dongdaemun project consists of an 86,574 square metre building, a plaza and a landscaped park. The core facility provides space for art exhibitions, conferences, a design museum, design labs and a media centre. Dongdaemun Design Park was one of the first projects in South Korea to use BIM, and a number of challenges led to its adoption. Firstly, the main building's freeform surface is covered in more than 45,000 unique double-curved aluminium sheet panels. The long and complex design, fabrication and installation process put pressure on both the programme and budget. Then, the unique freeform annex buildings had to be created from reinforced concrete. The project team was also very large and comprised of a number of leading practitioners working from different locations around the world. BIM offered a chance to address many of these issues. To construct the building's facade, the project team looked for a quick and affordable way of manufacturing the 45,000 aluminium panels. As each panel was unique, a way to mass customise panels without using fixed moulds was required. Sheet metal processing technologies considered at the start of the project could only deliver panels at a rate of 1 every 2 hours and at a cost of $7,000 per square metre. Eventually, the team developed a new hybrid sheet metal processing technology called multi-point stretch forming. The data determining the form of each panel was extracted from the building information models. Fabrication costs and timescales varied dramatically with each panel, but averaged between $250 to $400 each. The average fabrication time ranged from 15 to 40 minutes. Forming the unique annex buildings in reinforced concrete demanded highly accurate construction information from the design teams. The graphical information models were sliced every 30 centimetres. That cross-sectional information was then passed to the form workers who used it to form the complex reinforced concrete shapes. Despite having access to reliable and clash-resolved information in the graphical models, this formwork process was extremely laborious and considerably more expensive than conventional approaches. The project team experienced some communication and decision-making issues in the early stages. This led to the creation of an integrated design room, common ground where people could co-locate to discuss and make decisions about design issues. The teams used their information models as a tool for communication and decision-making, resolved many problems much more efficiently. Whilst many digital communication tools exist, and all the project's data is stored in a common data environment that could be accessed internationally, This approach demonstrates the power of having a venue for sharing, discussing, and resolving urgent issues on complex projects. Faced with the building's complex geometry, the Dongdaemun team worked in a BIM environment to identify clashes and to mitigate rework. This proved particularly powerful between the structure and the mechanical, electrical and plumbing systems. It was also used for coordination with the complex underground utilities of 2 nearby subway lines. Clearly, the primary use of BIM on the Dongdaemun project was in spatial coordination and in providing accurate fabrication data. But the project team felt that played a significant role in delivering the scheme successfully. For all the challenges faced, the project now glistens amongst South Korea's historic capital city, the first step in the country's BIM journey.
This is the references, and thank you for listening.